Okay, so let's start with y equals to x squared. And if you didn't, everyone should memorize that y equals x squared has the following graph. Y equals x squared is a parabola. If y equals x squared has this graph, can you tell me what the graph of y equals to negative x squared is like? Yes?
It's the same thing, but like upside down.
Yes. You don't have to raise your hand, just say it, okay? All right. And then, in general, a quadratic function looks like y equals ax squared plus bx plus c. And this is called the standard form of a quadratic function. And anytime this coefficient of x squared is positive, the graph will open up. Right? So, and anytime the coefficient of x squared is negative, the graph opens down. And a more technical way to say opens up is concave up. And this is concave down. Next is the graph of y equals to 2x squared. Okay, can somebody tell me what happens to this graph if you put a 2 in front?
It moves up twice. Moves up.
Okay, it's somewhat, yeah.
It stretches.
Stretches is the correct, more better word, okay? Yeah. So it gets taller because imagine that this picture is drawn on a rubber pad and you're stretching that rubber pad in the vertical direction twice, okay? So that's what happens to the graph. In other words, the graph becomes taller. But another effect that you see is that if you took this graph and you stretched it, then you'll actually see that the graph becomes thinner, right? Because if you stretch it this way, then these points are going to move up. You're going to get something like this, so it will get thinner, right? So another secondary effect that this 2 is going to have is it's going to make the graph thinner, okay? So being taller means it's thinner. Okay? So for example, if you had y equals to 10x squared, it'll be like very thin. That's what you're going to get. On the other hand, if you had something like y equals to 1/2 x squared, that's going to compress by 2 this way, right? So you're going to end up with something that's fatter because you're compressing it. Okay, now that we figured out what the graph of y equals to ax squared is like, when a is positive, it's opening up. A negative goes down. If a is a big value, it becomes thinner. If a is close to 0, it's like it's fatter. Okay? Let's think about something else that you can do to this graph. So let's say y equals ax squared looks like the following. Y equals ax squared. So some positive a. That's what we have. Now, if I take the graph y equals to ax minus 3 squared, can you tell me what happens to the graph?
It concaves down.
Yep.
It shifts to the right 3 times.
Yeah. It just this minus. If you replace x by x minus 3, it moves right by 3, right? So you go 1, 2, 3 steps, and this is where you have. So this graph gets moved 3 steps to the right. Okay. Furthermore, if I do y equals to a times x minus 3 squared plus 2, what happens?
Moves to the right 3 and up 2.
Up 2. This plus 2 is going to move it up by 2. So it's like 1, 2, 3 steps, 1, 2, and this is the graph. And you could say this is more like a generic form of a parabola. Um, and there's some features of this parabola that is prominent enough that they have a name. So one thing is that you can think of this vertical line, and this vertical line is prominent in the sense that if you fold this picture along the vertical line, then the left and the right side of the parabola matches together perfectly, right? So this vertical line has a name. This vertical line has the name axis of symmetry. How about this point? Well, this point is the minimum point of the parabola. In the case when it's upside down, it will be the maximum point. The minimum point or the maximum point of the parabola is called the vertex. This becomes another important thing when you try to solve optimization word problems later in the course. So it's a very important feature of the quadratic function. Now, can you tell me the exact position of this vertex? What's the vertex of this graph?
3,2.
3, comma 2, yes. It's 3, comma 2, because we moved 3 and went up by 2. And if you think about 3 and 2, those are exactly these two numbers, 3 and 2, right? And this gives rise to the following called the vertex form. So if you have y equals to a x minus h squared plus k, and this is called the vertex form, as opposed to the standard form, okay? They're both quadratic functions. This one is called the vertex form. That's called the standard form. And if you have the function written in the vertex form, this is advantageous because you can easily read off the vertex from it. So the vertex is going to be h comma k. And the axis of symmetry is a vertical line. Now, if you have a vertical line, what's the equation for a vertical line? It's always in the form of what? Okay, let me make it multiple choice. Is it y equals a number or x equals a number? X equals a number, right? So it should be an x equals a number, and because this is passing through 3, this has the equation x equals to 3. Okay? And this 3 matches with the x coordinate of the 3, 3 comma 2, because the line passes through the vertex. So they should have the same x coordinate, right? So you can say that the axis of symmetry is x equals to h. Okay? So we have a set of important formulas here and another one here. Now, you could choose to memorize this, but I did all this work so that you have some context behind why we get these formulas. It's actually a bad idea to just take this and try to memorize this, because you're going to forget it in 3 days. So something that I noticed many years teaching pre-calculus is that many of you overestimate your ability to memorize and underestimate your ability to reason. Does that make sense? Yeah, I think a lot of you do, which means if I take time to explain something, you would just forego everything that I said and just try to memorize this because you're somewhat confident in that you can memorize. But let me tell you something. You're not so good at memorizing. You don't remember that well, okay? If you just memorize this, you're going to forget it the next day or 2 days later. Uh, on the other hand, whenever you see that formula, you should always take the following view. You have y equals to ax squared, which is this one, and then you're moving this 1 to some direction h, and you're going up by k to get this new one. And because you're moving h to the right and k up, this is the resulting formula. And this will have exactly the vertex as h comma k. Now, if you take that view, when you read this formula, you will never forget it. Okay? If you ignore this and just try to memorize this, it'll last you 2 or 3 days at most. Okay? And you're going to have to memorize this before each exam, even the final. And at some point, it will be the list of things that you have to memorize will grow to a size that you can't really handle. Okay, so that's a really bad idea, right? So try to follow this reasoning. Y equals ax squared, which is this one. You move h to the right, k up, and therefore this is going to have h comma k as the vertex. You get that? Yeah. Once you get that, once it clicks, this is very natural. It's obvious, and making things obvious is the easiest way to learn math, right? Okay, so now that we have went through the formulas, let's do some examples. The hardest type of questions will be where you're given the standard form and you have to go to the vertex form. But because that's harder, the first example we'll go through, we'll start with the vertex form, and I'll ask you to do the standard form, right? So let me give you that question first. Everyone should try this one. First, you're given the vertex form, and the vertex form is a times x minus h plus k, so h is 3 and k is 5, right? So the vertex is going to be 3 comma 5, and the axis of symmetry is going to be, well, it's going to be x equals to this first number. Whatever that number is, this is what it is, okay? B, does the graph open up or down?
Down.
How do you know? Because of the negative 2. So if the very first number is negative, then it's concave down. Whereas if the graph, the very first part is positive, then it's concave up, right? So the answer to the part B is that it's concave down. Now, how do you get to the standard form? Well, you just have to expand this out and simplify, then you get the standard form of this form, okay? So let's try that. Y equals to negative 2, x minus 3 squared plus 5. And you can rewrite x minus 3 squared as x minus 3 times x minus 3. And then you have negative 2 times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And then negative 3 times negative 3 is plus 9 plus 5. Now, you're seeing an expert do a math question, right? So you should pay attention not just to the content, but look at what the master does, okay? The most beautiful that I'm doing here is this parenthesis, okay? A lot of you will will forget this parenthesis and end up making a mistake. Because if you forget this parenthesis, you're going to end up forgetting to multiply -2 to 9, for example. Okay? So when it comes to doing algebra, a lot of the mistakes happen because you are skimping on your parentheses. Okay? Try to put your parentheses as much as you can. All right, okay, let's continue. -3x and -3x are like terms, so that becomes -6x. And now we can multiply the -2 to each one of these. So we get -2x squared plus 12x minus 18 plus 5, so that the standard form is going to be y equals to -2x squared plus 12x minus 13. Okay. That's the answer to part C. Now, I did this to make sure that everyone can follow, but there's a shortcut from here to there. Do you remember the shortcut? If you have a minus b squared, what do? Square the first. X squared gives you x squared. 3 squared gives you positive 9. -3 squared becomes positive 9. Right? And then there's a middle part, which is the double the product, right? X times -3 times 2 gives you -6x. If you did that, then you can skip these 2 steps and go from here to there right away. And whenever you can do these kind of shortcuts, it reduces, not only reduces the writing, but it reduces the chance to mess up. Okay, and those are very important things. Okay, so hopefully you can also learn how to do it in that way. But that's it. That's the answer to this. Now, what we just realized is that this is same thing as y equals to -2x minus 3 squared plus 5, right? So, but the hard part is now, how do you go from the standard form to the vertex form? Okay. So let me show you how that's done. Okay. So here's a question I want you to think about. Question: find the vertex form of y equals to -2x squared plus 12x minus 13. And the solution relies on something called completing the square. What you do is, if you're given an equation, completing the square says, first, move the constant term to the other side. So I can add 13 both sides so that you get y plus 13, and that 13 is gone because -13 and plus 13 goes away. Right? That's step one. Now, here's where it gets tricky. You probably have learned completing a square at least once in high school, but it was so complicated you just forgot it a week later or something. Yeah, I think a lot of you may share that experience, right? And that hard version of the completing the square has to do with the general case when the coefficient is not 1. Okay, if it's something like -2, that becomes much more challenging completing the square problem that's in more general. Okay, but because that's too much, let's just handle the easiest case where you don't have any coefficient. In other words, the coefficient of x squared is just 1. That case is a lot easier to handle when it comes to completing the square. So I want to make this -2 as 1. How do you do that? You can just divide both sides by -2. Okay? So I'm going to divide both sides by -2, with the sole purpose being so that this -2 goes away and you just have x squared. Okay? Now 12 divided by -2 is -6, so you have y plus 13 over -2 equals to x squared minus 6x. Okay. Now that this is just 1, coefficient of x squared is just 1, completing the square is quite easy. Okay. Does anyone know how to do this? Completing the square after this? Yeah?
You square root it, cancel out the power.
No, that's not how we do it. Okay, well, there are 2 steps. So step 1, take half of coefficient of x. Okay, in this context, what's the coefficient of x? Negative 6 is in front of x, right? What's half of that?
3.
Negative 3, okay? And once you get that negative 3, step 2, add the square of that number both sides. Okay. So since we got the negative 3 by taking half of this, negative 3 squared gives you 9, and that's the number that we are going to add both sides. So we have y plus 13 over negative 2 plus 9 equals to x squared minus 6x plus 9. And then you factor the right side. It's factoring trinomials. The way you factor trinomials is you look for 2 numbers that add to the middle number and multiply to the last number, right? And you can easily see that negative 3 plus negative 3 is negative 6. Negative 3 times negative 3 is positive 9. So negative 3 and negative 3 works. In other words, this factors as x minus 3 times x minus 3. But what's that? That is exactly a square. It's a square of something. That's what it means to complete the square. I've made this into a square of something. Okay? So I get the following identity, y plus 13 over negative 2 plus 9, but we're not done yet because we still have to solve this for y without changing this one. So this x minus 3 squared should be kept as it is. You just have to continuously just solve for y. Okay, so let's continue it here. So let's subtract 9 both sides, so then you get y plus 13 over negative 2 is x minus 3 squared minus 9. So I subtracted 9 both sides. And now you multiply by negative 2, so that y plus 13 is negative 2 times this guy, x minus 3 squared. And negative 2 times negative 9 gives you positive 18. And then you subtract 13 from both sides. So you get y equals to negative 2 x minus 3 squared plus 5. And as you can see, this is indeed this vertex form that we started with, right? We got this from here by expanding, right? And we successfully went backwards. In math, there are many examples where going backwards is harder than going forward, and we succeeded in it. Okay. Okay, so this is the method of completing the square. However, because it deals with so many steps of algebra, it's easy to mess up. So I want to show you the second method, which is shorter. But I still want to show you this one for 2 reasons. One is like many of you were taught this way and not the other way. So I just want you to refresh your mind. And another reason is that when it comes to circle equations, this is the method. Okay? There's no other method. You have to use complete the square to figure out the graph of a given circle and stuff like that. So you're going to do it anyways at some point. So that's why I did this. But let me show you the second method because it's probably easier. It's probably easier. Okay, but before I show you the second method, I need to go over the formula. And I don't want to just throw you the formula and ask you to memorize it because that doesn't work, okay? I want you to actually understand where the formula comes from, okay? So let's say we have y equals to ax squared plus bx plus c. And let's assume that it also has x-intercepts. Okay, so the parabola sometimes might be graphed too high and it doesn't meet with the x-axis at all. But let's assume the case where it does have the x-intercepts. Okay. Now, the most important observation that you're going to make is the fact that if you look at the vertex and the two zeros, these are called zeros or roots, the two roots, that then this vertex, the x-coordinate of this vertex is right at the middle of the two roots. Do you agree? It's right in the middle. Right? So maybe there's a way to get the x-coordinate of the vertex from the two roots. So that's the first idea. Now, how does that work? Well, it works by first figuring out what these are. Well, how do you get the x-intercept? To get the x-intercept, you set y as 0. To get the y-intercept, you set x equals to 0. Does that ring a bell? You've heard that somewhere before, right? Okay, so to get the x-intercept, we're going to set y as 0. And we see that the x-intercept will satisfy ax squared plus bx plus c equals to 0. I know the solution to this. What's the solution to this? X equals negative b plus or minus square root what? B squared minus 4ac all over 2a, right? It's a quadratic formula, right? Now, when you see the quadratic formula, it can be written in the following way. You can rewrite this as negative b over 2a. You can rewrite this as negative b over 2a plus or minus square root of b squared minus 4ac over 2a. Now, it looks horrible. In fact, the quadratic formula is the ugliest formula in all of algebra. But there's no way around it. You have to memorize it. Okay. If you had a hard time memorizing it, please try to learn it as a song. Okay. Of course, I have a YouTube channel and I sang this with a keyboard, so you can watch that video too. Okay. So that's quadratic formula. But let's forget about the fact that there's some horrible formulas. Just focus on how it looks like. You have something, and then plus minus something else. Right? So think about the following. What if you had 5 plus minus 2? What does that mean? That means if you add 5 plus 2, that gives you 7. And if you subtract 5 minus 2, that gives you 3. So 5 plus minus 2 represents the two numbers 3 and 7. Here's the question. What's the midpoint of 3 and 7? 5. Yeah? Now, why is that? Well, there's an obvious reason. Here's 5. Plus 2, 5 on the number line, right? Plus 2 means you're going right by 2 to reach 7, right? Minus 2 means you're going left by 2 to reach 3. Since you went right and left by the same amount, if you ask what's the midpoint, it'll be this one in the middle without the plus and minus. Do you agree? Okay. In other words, if you look at the quadratic formula and notice that it's plus or minus, then you can see that this portion would just be the midpoint. Do you agree? Yeah. So this will be the x-coordinate of the vertex where we called it as h, right? So we have a very important formula. Maybe I should write over here. H is obtained by negative b over 2a. Of course, once again, I could have just given you this formula to memorize, but you're going to forget it, okay? Rather, you should be able to answer where this formula came from. Where did this come from? From? What is this thing called?
A quadratic.
Quadratic formula, okay? So if you take the quadratic formula and delete the square root part, because that's where the plus minus is applied, right? If you just simply delete the square root, you get a very simple formula. That resulting formula gives you the x-coordinate of the vertex. You get it? Okay, but doesn't that just address half the question? The original question is looking for h and k, right? Because if you want the vertex form, you need both h and k to get the vertex form. How are we going to get the k? Does anyone know? How do we get the k once we know the h? Any ideas? Well, here in this picture, we're saying that this point is h, right? How do we get the k? If you know the x coordinate, how do you get the y coordinate?
So x is 0.
No, that would be like getting the x to 0 will be getting the y-intercept. Yeah. How do you get the y coordinate if you know the x coordinate? Well, how is this graph drawn? If you're given a graph, you plug in values of x to get the y coordinates. You plot them, and that's how you get the graph, right? So if you knew that, then you would know that if I know the x coordinate, all I have to do is plug it into the function and get the y coordinate from it. Okay? So the strategy for getting the k is to plug in h into the function. Now I'm just going to simply write it like this. K is obtained by plugging in h into the function. Okay? You just plug in h into the function where this f means this. Or yeah, it means this. Okay? You just plug it in here, and that gives me the k. So let's see how that works. You're going to solve the same question, this one. Okay, first of all, what are my A, B, C? A is negative 2, B is 12, C is negative 13. And because H is going to be negative B over 2A, where do I get this from? The quadratic formula, okay? You just delete the square root part. This is what you get, okay? And then minus B is 12, 2 times A is negative 2, and that has two negatives, so negatives cancel, giving you positive, and you have 12 over 4, which is equal to 3. Okay? That's your H. How do you get the K? How do you get the K? F of 3. F of 3, right? You just plug in that value into the function. Now, what do I mean by that? Well, to plug in, we went over this last time. You just empty out the x's, put parentheses there. Okay? Another beautiful work of not forgetting the parentheses. Yeah. As I said, forgetting parentheses is the number one mistake. Okay? Yeah. So just like the number one reason behind car accidents is drinking and driving, right? Number one reason behind making mistakes in algebra is forgetting your parentheses. Right? Okay, so you plug in 3 into the parentheses, and that gives you a negative 2. 3 squared is 9, so negative 2 times 9. 3 times 12 is 36. Minus 13. Negative 18 plus 36. Minus 13. 36 minus 18 is 18. 18 minus 13 is 5. Yeah, so here, these two give you 18. 18 minus 13 is 5. Okay, so we got the vertex H and K. Now what do? You have to remember the vertex form. Where A is same as before, it's negative 2. H is 3. K is 5. Done. And that agrees exactly with the previous answer, right? So we got the same answer as before. And the point is, we did this without having to go through completing the square. Okay, completing the square had several algebraic steps. It was very easy to mess up any one of those steps, right? Here, we just did 2 calculations and bam, we have the answer, right? So I say this is like only half the effort as the complete the square. So I would want everyone to try it this way. Get it? Okay, so let me now put another question. So h is equal to negative b over 2a. K is equals to, you plug in h into the function. Those are the two things that you have to know. Plus y equals to a times x minus h squared plus k. And of course, when you think about this, always think about y equals to ax squared, moved h to the right and up by k so that the new vertex will be over here, h comma k. And if you move this h right up by k, this is the formula you get, okay? You have to learn from the masters, like people who really know what they're doing, okay? Yeah, so when I try to explain it in some form, you should pay attention, not looking at your screen. You should really pay attention at what I'm saying, okay?
Sure.
Yeah. You're missing out on something very important if you're not paying attention to this part. Okay, so here, what's A? A is this one, and B is this, and C is this. Okay. So we have H equals to positive 12, that's B. A is negative 3. So you get minus cancel, so you have 12 divided by 6. And 6 times 2 is 12, so 12 divided by 6 will be 2. And therefore, K is going to be plugging in 2 into F, where the function itself is that thing, negative 3 squared, plus 12, parenthesis, minus 5. And you're plugging in 2 into the blank spaces. And that gives me negative 12 plus 24 minus 5. And that gives us negative 12 plus 24 is 12. 12 minus 5 is 7. Now plug these into the vertex form, and I have y equals to negative 3. A is the same thing as before, negative 3. X minus 2 squared plus 7. That's the vertex form. That's the answer to part A. What's the vertex? We got it here, 2 comma 7. That's the vertex. What's the equation of the axis of symmetry? It's a vertical line, so it should be x equals a number, yes?
X equals 2.
Yeah. So axis of symmetry is x equals to 2. Now part C, we have to find the y-intercept. How do you get the y-intercept? Well, you plug in 0 into x. To get the y-intercept, you plug in 0 into x. To get the x-intercept, you plug in 0 into y. Okay, just remember that. So you have y equals to -3. Again, because you're plugging in, try to copy the definition down. So copy the formula down, and then you plug in 0 there. But this is 0, that's 0, so you just get -5. Right? Okay, so we have the vertex and the y-intercept. Part D says you have to sketch. How do you sketch it? Well, the way you sketch it is by first going to 2, 7. So 1, 2 steps, 1, 2. Oh, I guess it's somewhere here. Let's say this is 7. 2, 7. That's the vertex. So from the vertex, you either open up or open down. Okay? Which one is it?
Down.
Down. How do you know?
Because
Because of -3. So it opens down. And also, -5 is the y-intercept, which means here's -5. And it's a point on the graph. So as it goes down, it better be passing through this point. Okay? So that's the graph. This is the graph of the given. Okay? All right, so let's do another one. Let's see. Let's put all of them plus. H is equal to 18 divided by -18 divided by twice of 3, which is -18 over 6, which is -3. K is F. You plug in this number into the function. So it's 3 squared plus 18 squared plus 1. And -3 goes in there. That's going to be 27 minus 54 plus 1, which will give you -26. That tells you that the vertex form is y equals to 3x plus 3 squared minus 26. It's plus 3 because it's minus -3, okay? And then the vertex is going to be what? -3 comma -26. X equals to -3 is the axis of symmetry. And then when you plug in 0 here, you just get a 1 as y-intercept. And then here's 1. Here's -3 and -26. And because this is positive, the graph opens up as to pass through this point. So that's the graph. Okay? That's all for today.